6th grade, Module 4, Lesson 6, Classwork. Example 1, expressions with only addition, subtraction, multiplication, and division. But first, before we start that, this is all about order of operations. And if you remember order of operations from 5th grade, what we used was the acronym GEMDOS. So the G stood for grouping, like parentheses, brackets, and braces. E stood for exponents. M and D stood for multiplication and division. And A and S was add or subtract. So this is the order in which we solve different equations. So let's start answering the questions. But remember GEMDOS. That'll help you always remember the order in which we solve a problem. So what operations are evaluated first? So first, it's only talking about addition, subtraction, multiplication, or division. So between those, if we're looking down our GEMDOS, if there's no grouping and no exponents, we're just talking multiplication, division, and subtraction. Remember, we solve multiplication or division first. Or division, and remember we solve it from left to right. So it's whichever comes first. So if a division problem is first in the problem, we solve that first, and then we solve the multiplication problem next. It's just whichever order they're in. What operations are always evaluated last? So last is addition and subtraction. So again, left to right, whichever comes first. And we'll do some examples to refresh your memory from 5th grade. Okay, exercises 1 through 3. 4 plus 2 times 7. So if we're talking GEMDOS, I'm going to write that out again. There's no grouping, no exponents, but there is multiplication or division. So I'm going to solve 2 times 7 first. So we have 4 plus 14, and that would be equal to 18. The next one, 36 divided by 3 times 4. So we do multiplication or division, whichever one comes first. So since the division problem comes first, we're going to do 36 divided by 3, that's 12. And do 12 times 4 is equal to 48. 20 minus 5 times 2. So here, we have to do multiplication first. So we have 20 minus 10 is equal to 10. Okay, now we're making it a little bit difficult by adding in the exponents. So we're going to add in the E part of GEMDOS. So what operation here would be solved first? Here we would solve the exponent first, the exponent being 9 to the 2nd power. And 9 to the 2nd power is the same as saying 9 times 9, which would be 81. What do we evaluate next? So after we have it as 4 plus 81 divided by 3 times 2 minus 2, next I'm going to look left to right because all we have is addition, subtraction, multiplication, or division. So I'm looking for any multiplication or division problem from left to right. The first one I come across is 81 divided by 3. And 81 divided by 3 is equal to 27. So let's rewrite 4. So we have 4 plus, we did 81 divided by 3 is 27 times 2 minus 2. So next we would do the multiplication. of 27 times 2. 30 times 2 is 60, so minus 6 would be 54. So we now have 4 plus 54 minus 2. So next we're done with all the multiplication or division, so now we can just solve it left to right, and we have an addition problem of 4 plus 54, which equals 58. So we now have 58 minus 2. So lastly, we have subtraction of 58 minus 2, which is 56. So our final answer is 56. Okay, so now we're going to do it with just some problems. We don't have to write out all of our steps like we were doing before. Okay, 90 minus 5 to the second power times 3. I'm going to write GEMDAS to remember our order. So there's no grouping, so we move on to the E. Are there any exponents? There is, right here, 5 to the second power. So 5 to the second power is 5 times 5, or 25. So we have 90 minus 25 times 3. So there's no more exponents, so we're going to move on to multiplication or division. There is a multiplication problem, so we look left to right, and we have 25 times 3. So 90 minus 25 times 3 would be 75, and then we just need to solve 90 minus 75 would be equal to 15. And number 5, 4 to the third power. So there's no grouping, but there is an exponent. 4 to the third power is equal to 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. We have 64 plus 2 times 8. So there's no more exponents. So we're looking for multiplication or division. We have 2 times 8. So 64 plus 16. And 64 plus 16 would be equal to 80. Okay, now example 3, we're adding in the parentheses or the grouping symbols. So consider a family of 4 that goes to a soccer game. Tickets are $5 each. The mom also buys a soft drink for $2. How would you write this expression? So family of 4 goes to a soccer game. The tickets are $5 each. So I see 4 times 5, because 4 people, $5 each. So I would say 4 times 5, and then the mom buys a soft drink for $2. So then they spend an extra $2 on soft drink. I see 4 times 5 plus 2. So how much would this outing cost? Well, 4 times 5 would be 20 plus 2, so it would cost $22. Consider a different scenario. The family goes to the game as before, but each of the family members wants a drink. How would you write this expression? So there's different ways to do it. So remember, each person costs $5. So we still have the 4 times $5, but this time everyone wants a $2 drink. So we could add to it 4 people times 2 drinks. So you could write it like that. That's one way to write it. Or we could simplify it, and we know that there's 4 people, and if each person, it costs $5 for a ticket, and it also costs $2 for a drink, we could just do that. So each person costs $7. And it needs to be in parentheses like this because we want to add before we multiply. And if we just wrote it like that, we would be doing the 20 plus 2 first, and we would get a different answer than if we did 4 times 7, which is 28. So we need those parentheses there. Why would you add the 5 and 2 first? We kind of already talked about that, because we need to know how much each person spends. So we need to know So they each spend $7, and then we multiply it that by 4 people. So how much would that cost? So we have 4 times 5 plus 2 is 7 would be equal to, it's going to cost $28. How many groups are there? So we would have 4 groups. 4 groups. The groups are really talking about people. And then what does each group comprise? So that would be the 5 plus 2. So it would be $5 per ticket and $2 per drink. Or we could say $7. Exercises 6 through 7. So now they're throwing it all at us. We have the grouping, we have the exponents, we have the multiplication, division, addition, and subtraction. So we're going to start with grouping. So we have parentheses right there, so that tells us we need to do this problem first. 9 to the second power minus 4. So within there, we need to solve 9 to the second power, 9 squared, first. So 9 squared is 9 times 9. So I'm going to simplify it to 2 plus 81 minus 4. And now I still need to solve the grouping. 81 minus 4 is 77. So 2 plus 77 is equal to 79. Number 7. 2 times 13 plus 5 minus 14 divided by 3 plus 4. Okay, so we need to start with the grouping, which we have parentheses here, and we also have them here. So when there are parentheses within parentheses, we need to start with the thing that has parentheses around it, the smallest problem there. So that would be this 3 plus 4. So let's just start there. So we have 2 times 13 plus 5 minus 14 divided by 3 plus 4. I'm just going to simplify that to 7. Okay, so we already got rid of one grouping symbol. Now we need to look within the grouping that we still have and follow GEMDAS. So there's no more grouping in there. There are no exponents, but we do have multiplication or division. So I'm going to solve this 14 divided by 7. So we have 2 times 13 plus 5 minus 14 divided by 7 is 2. And I'm just going to keep going. So 2 times, let's see, now we just have addition and subtraction left, so I'm going to solve it left to right. 13 plus 5 is 18 minus 2. 2 times 18 minus 2, we're not going to need the parentheses anymore, is 16. And 2 times 16 is equal to 32. Example 4. We have 2 times 3 plus 4 to the second power. Which value will we evaluate first within the parentheses? Evaluate. So first, we're going to evaluate, let's see, what value will we evaluate first within the parentheses? 4 to the second power, because we're going to do exponents first. 4 to the second power is 4 times 4, which is 16. So let's evaluate the rest of the expression. So now we have 2 times 3 plus 16. So we need to continue solving what's in the parentheses. 3 plus 16 is 19. 2 times 19 is 38. What do you think will happen when the exponent in this expression is outside of the parentheses? So now, instead of, notice it was inside. The last problem was 2 times 3 plus 4 to the second power. So the exponent was inside the parentheses, just attached to the 4. When it's outside, that means that we're going to square this whole thing. the whole 3 plus 4. So it's really 7 squared. So what do we think will happen when it's outside? So I'm going to say it will be bigger. It will be larger because we are squaring, I don't know if that's a word. We're squaring 7 instead of just 4. Okay, will the answer be the same? No. What should we evaluate first? So first we're going to evaluate what's in the parentheses. So first we're going to do 2 times 3 plus 4 squared. So we have 2 times 7 squared. So what happens here differently here than on our last example? So different here is that we added 3 and 4 before, or instead of 4 first, instead of finding 4 to the second power. So what should our next step be? So the next step is going to be the exponent. So we're going to do 2 times 7 to the second power, and since 7, it's just 7, we don't need the parentheses anymore. So it's going to be 2 times 7 to the second power is 49. Evaluate to find the final answer. 2 times 49 would be equal to 98. What do you notice about the two answers? So we had 98 and the last answer was 38. So they are very different. So they are different. What was different between the two expressions? So let's just say in the first problem, the exponent was inside the parentheses, and in the second, it was on the outside of the parentheses. What conclusions can you draw about evaluating expressions with parentheses and exponents? So it doesn't matter where the exponent is, we always evaluate the parentheses first. These first, regardless of the location of the exponents. Okay, let's keep solving. 7 plus, in parentheses, 12 minus 3 to the second power. So first we have grouping, which would be here. So I'm going to do 7 plus, but within the grouping, we need to do the exponents. So 12 minus 3 to the second power is 9. So now I'm still going to stick with what's in the parentheses. So 12 minus 9 is 3. So we get 10. 7 plus 12 minus 3 to the second power. So we have 7 plus, this time the exponent's on the outside. So I can solve 12 minus 3. That is 9. So now I need to do the exponent. 7 plus 9 to the second power is 81. 7 plus 81 would be equal to 88. And that is the end.